Okay, so this is a dynamic programming question I did today. So the question is called Coin Combinations 1. It's a pretty classic question for dynamic programming. So we consider a system consisting of n coins. Each coin has a positive integer value. Your task is to calculate the number of distinct ways you can produce a money sum, X, using the available coins. For example, if the coins are 2, 3, 5, desired sum is 9, there are 8 ways to do so. So basically, we're given N and X in the first line, which is the number of coins and the desired sum of money. And then the second line has N integers, which are the values of each coin. So where our outputs is the number of ways modulo this number. Okay, so this is a pretty classic. We just count the number of ways that we can form it from all the other something like if our current value is n, we're gonna look for the sum of all the ways to form n minus c, like which is c is like the coin. All of those ways plus up together would just be the sum of the ways to form n, right? So that's how we're going to do it. So let's walk through the code. Include bits std c++.h using namespace std. Pretty standard. I used using ll equals long long because in this question I don't want to exceed it just in case. And then in my main I have my n and x. I define my m which I use to modulo. Then what I do is I have my n and x and I input them. Next, I initialize my DP based on the number of X, like whatever my X value is, I just do one more than that because I have zero including to X, right? So that's why I have X plus one and then initialize everything to zero. And I initialize the first value zero as one because there's one way to get nothing, right? I just pick nothing. Next, I initialize my coins array with n elements and I input my elements inside here. Then what I do is this is like the major kind of like the core logic behind the dynamic programming is that I first go through the value as I go from 0 to all the way up to including x. And then I go from j from 0 to n. So I go through all the coins. If the coins like I minus coin j, basically meaning if my difference is still inside the thing and it's not negative, then my number of ways to do so would just be that way plus my original way, modulo m, just making sure it doesn't exceed the bound. So basically every kind of way works. And then in the end, after going through all of the things, then I know that the final thing I'm looking for is just the DP at X, right? That's my final thing. So I just return that, output that, and then I return 0. I think this question is really a standardized question for DP. There's really not much anything to say for this. This is just making sure that you know each coin is within that and making sure you set up the boundaries that nothing negative is included so you don't have any index errors. Cool. That's enough here.